So I start. So hello. I'm going to be talking about search engines and how the score of a document is computed. So first, hi, I'm Nerea, and this is Panda. It's going to help you stay calm all along, I hope. So I'm a PHP engineer, and also I'm an artist. And I work with Drupal, with Symfony, and any kind of architecture of any kind of project, PHP project. So that's me. On the first part, I'm going to talk about the vocabulary behind the search engines.
Can you speak up a little bit?
Yeah, I'll try. The first part will be the vocabulary about search engines. I'm going to try and make it more understandable with parallel with a library. We're going to see some math behind Elasticsearch, which will be my search engine for this presentation. And then we're going to see how us as developers can play with the scores, can try to change the score. And then we're going to see how we can do that with Drupal. So a little question first. How many of you have already set up search engines on a project, whatever type of project? Oh, so this will be just a reminder for you then. Sorry. So, as you may already know, the things, all the textual information you want to search on will be called the documents on a search engine. So that's it. And then each document will go through a tokenization process. And these tokens will help to create an inverted index. Alexander talked about it on Wednesday, but I'm trying to go a bit deeper on each one. So the first one, the tokenization process, is just we create tokens from the text we have on our documents. So it's really used on any lexical analysis like PHP style, which helps us to have a clean code. And the easier way to try to imagine how they work is just to break up the sentences or the text into words. And each word will be considered a token. So if we keep that in mind, this beautiful sentence here, you can transform it into token. And I think you guessed it. That's the result of the tokenization for this sentence. And then we have to create our inverted index. So what it is, it's a map from each token that we have generated to all the documents where this token appears. And you can think of a recipe book. And sometimes at the end of a recipe book, you have an index where you have all the ingredients for all the recipes on the book. And you can find for each ingredient in which recipes it appears. So if I want to do something with chocolate, I just have to go to the end of the book and find what I want to do with chocolate, instead of looking each recipe on my book and see if they use chocolate or not. So again, we go through the tokenization process here. We create our tokens for each document. And then we find all the unique tokens from those lists of tokens. And we can map them to the documents where they appear. So if my user is searching quick, our search engine will easily find that quick is used in document 1 and document 3. So that's one side of the search engine. And from the other side, we will have the user input, which will be translated into the query used by our search engine, so specific to the search engine. And then the query is used to process on the inverted index to find for each document the better score based on the user query. And that's it. That's all the basis you needed to know. And if I want to make you understand it better, let's try with an example. So that's me. I'm a bookseller, and I have a bookshop. I don't have a computer. I don't have anything to try to make the search for me, so it's all in my mind. And those are the books behind me on the shelf. So those are the things I have. And that's you. You enter my shop, and you want something from my shop. And obviously, you didn't ask just fantasy, right? You say hi, maybe how are you? And maybe a lot of sentences, which I clean up and keep the essential, which is you want something that's related to fantasy. And with that, I can start searching something that's relevant for you. Well, but you're still not happy. Too much things on my book. So we keep talking. You keep adding things, and I keep cleaning it up, and I keep the essential, which is this one. So I can find again the books that are related to you, to your search. And we can go on and on and on. But this time you tell me that Phoenix it's something you need. And I found the only book that's related to your search, and that's it. You have all the things you need. You want it or not, that's your problem, but I found it. So if you take that into the schema that I showed you before, my books are the documents. So that's all the textual information I'm going to be looking into. I am the inverted index because I have all the knowledge of the books, so here documents. And obviously you were the user. I think you guessed it. And now we're going to see some math. So just don't be afraid. I don't like math. I'm very bad at explaining math, so I'm going to try to make it simple for everyone. And as I said before, I'm going to just use Elasticsearch as an example. But the notions can be used on any search engine behind. So I'll try to demystify all these notions here, because even if they seem complex, that's all you need to know to understand how the score the calcul behind the score works. So we're going to have first the inverse document frequency. So it's just a way to let us know if a term on the user query is important. Yes, it's important on the document. So let me explain it better. So let's say that's your query. So it's Harry Potter and tragedy. Harry and Potter that I found many times on my documents, over all my documents. So they mean it's quite obvious that it's here. While tragedy, it's something that's rare. So it means it's more important for the user to know that's something rare on the documents. So the more frequently the term appears, the higher the more frequently the term appears, the lower the inverted document frequency will be, because it's less important for the user. Then we have the term frequency. So this one is quite obvious. It's going to just say how much a term appears on a document. So if I have two documents here, and I try to find a mouse on them, I think you can easily do the math. So I found it twice for the first one, over the 8 terms that the document contains, and 1 for the second one. So that's it. This one is quite easy. And in the end, we have the coordination factor, which is quite simple too. It's just knowing how much the query of the user, the user's query, will be found on the document. So if I try to search mouse, it's binary because my query just have one term. Either I found it on the document, either I didn't. And it's not really useful, just one word, one term. So if I try to do the same thing with more terms on my query, you start to have something that's interesting for the score for the score of the document. And with that, you have all the things you need to know to understand how a score is computed, And all that does a score is just to show to the user the more relevant documents, so to rank them up for the user, to say this one is better than this one. So again, if I try to search the same things, since Phoenix is a term that's rare, since I found the 4 terms of my query and everything, the order of the Phoenix is more important for the user than the other ones. But I still didn't tell you how to compute a score. And that's where the math appears. So as I said, I don't like math. And the algorithm behind Elasticsearch or any other search engine is quite difficult for me. So what I'm going to do is simplify it. And we're going to understand the process behind, but only using the 3 notions we've seen here. And that's it. But just for you to know, this is the one behind Elasticsearch. As a simple sentence, it's a ranking function that's going to be used by search engines, obviously, that estimate the relevance of a document based on the user query. And all of that with that much things. So to simplify my life, to simplify your life, I'll be using this one. I didn't invent it. I took it from a conference at Paris by Matthias, who talked about search engines too. And I don't remember if he found it or if he created it based on the algorithm before, but I found it quite simple to understand and to follow. So we have the 3 notions we've seen before, and with that we can calculate our score. Since books are my passion here, and it's simple to understand, to take an example with books, we're going to do the same thing. So that's me again, that's you again, and so the difference here is that this time I have a computer. I have a software behind that's going to compute the score for me, and it's going to show me how it works, how it's going to compute this score. So you're looking for Fanta because fantastic and fantasy didn't match all the way, so I tried to find a middle ground. And let's try to let's start with the term frequency. So I did found it for the first one once. I found it for the second one once. I found it for the third one twice. I have my term frequency, and it hides somewhere behind. It doesn't show up. We can go with the inverted document frequency. And from my 4 books on my shelf, I have 3 that contains the term of the query. So it's easy to compute this one. And the last one is going to be the coordination factor. So I have only 1 word on my query. It's easy, binary, 1 or 0. And that's it. We have the Fantastic Beasts and where to find it, that's first, obviously, because everything was better for him. I have Narnia and Hunger Games that's going to fight for the second place. And it doesn't show up again for the user. So you can see that with 1 word, it's quite not, how I can say that. It's going to be really simple, so it's not going to do lots of, I lost my words. Comment on dit?
Computation?
Non. In French, ça serait, ça fait pas grand-chose, quoi. Well, it does something, but it's not quite interesting for the user because there is not quite difference of the computed scores here for each book. So let's try to add something more because why not? We're here to have fun with maths. So let's add Narnia. And with Narnia, we can start updating the coefficient factor. This time it's not binary, so it's more interesting for us. We can go keep with the other two ones, the other two. Again, Narnia it appears only for Narnia, so that's easy for the term frequency. And the inverted document frequency, I did find Narnia on one document over my 4 documents, so it's quite rare, which gives him a boost. And this time I have totally changed how the query is going to show up for the user, which is normal because Narnia is more important than the other two. So Narnia is first, Fantastic Beasts is going to be second, and Hunger Games is the third. It doesn't show up again because it's not relevant for the user. So the user's query is quite important, but you can see a bit better now how all these notions work together to keep the relevant things for the user, to show the relevant things to the user. And as I said before, it can be found on any search engines. It can be called named differently and use a different algorithm behind. But the idea of what it do match if all the terms of the query match on a document, and all these ideas are the same. Maybe are just named differently, maybe they are computed differently, but it's the same idea. But I did lie to you. That's not it. There's a lot more things on a search engine that you can use. You can use boosters, you can use function scores, you can play with the user input. Well, the user can play with its input, but you can plan how it's going to be translated to the search engine. But that will be for another time. So, and for us, as developers, we can't do anything about the algorithm behind the search engine. We can't do anything about what the user is going to input on the search input. So what we can do is play with the settings of our indexes by using the analyzers. Those analyzers will modify how the search engines will process our documents. And there are 3 types of analyzers. There are character filters, which quite simple is going to add, delete, and modify characters on the text. Then we're going to have the tokenizers, which we see before what they do, and the token filters, which does the same thing as the character filters, but on tokens. So I'm not going to be talking about character filters because they're quite specific, like HTML, do something with the HTML, do mapping, do replace. So I'm not going to talk about it because my examples are quite simple here, just for the example. But we can try to go with the second step, which is the tokenization. So these are my tokens for my books. And I can try to filter them on. So lowercase, everyone is on the same height. Stop rows, I remove what's useless, for the search, I mean. And I can go on with that, but I think you got the idea. In this part, I'm going to just show you how much they can impact the score and how the configuration means something on this score in the end. And for you to know, I have different indexes. They configure differently, and I will explain each one each time. And they have the same 15 books every time. My query is quite simple. I'm just looking for epic on the description, so that's quite easy to see. And let's start with the first one. I only have a tokenizer here, which is the n-gram tokenizer. I found 7 books on my search, and the first one which I was looking for is The Lord of the Rings. So it's the first one. Yippee, it works. But I found 6 more, and I don't know why. This could be explained if we look at the Elasticsearch description for the n-gram tokenizer. which means that it's a sliding window that opens and closes and moves around the words from a minimum size to a maximum size. So I have my sentence here. I have my first window open to the minimum size. I can open it to the maximum size and slide it up to each character of my text, which will, in time, create these tokens here. So for Epic, it would create that tokens. So I didn't look for Epic on its own. I did look for E, IP, and all these things, which you can see that that's why I got 7 books instead of just 1, because I didn't look for Epic. I did look for all of these things at once. So we can try to play along with EdgeGram. I did find 1 book. I have a score of 6 instead of a score of 1 point, I don't know. And it's the good book, so that's fine. I did find my book. And the EdgeGram, even if it's based on the Ngram tokenizer, they work quite differently. It's not going to move across the text. It's going to move across the words of the text. So again, quick focus, I like focus. I open my window to the minimum size here, and I can open it until I got to my maximum size. And then once I got it, I go through the next word and do the same thing again and again and again. So for Epic, I got all these 3 tokens here that's going to be used for the search. And it seems that they didn't appear in any other book than just the Lord of the Rings. And I can do the same thing just within the standard tokenizer, which is the word-by-word tokens. And use the filters. So lowercase, it doesn't do anything useful because Epic is already in lowercase. So I found Epic, that's nice. I found the Lord of the Rings, that's cool. I have a score of 2 point something, that's cool. I can go on, I can try the steamer, but the roots of Epic is still Epic, so it doesn't do anything. I found 1. I found a good one. I can do the same thing with the stop words. Epic is not a stop word and doesn't do anything else. I keep having a score of 2 point something. And I can try to mix them up together. So I can't have 2 tokenizers because once I have tokens, I don't need to go through a tokenizer again. So here I choose the Ngram tokenizer because it's fun. And I did put all the filters inside. And you can see that my book is the 4th one on the list of 7 books. That its score is 0.6 something. And even though we now understand how the Ngram tokenizer works, but since we put together all the filters, so the stop words might have removed some stop words that might have been created by the tokenizer before, which means that from my little text of description, it might have removed a lot of things, whereas for the other descriptions that are much longer, I can find more often the tokens I was looking for. So I know these are just examples and really easy ones, but you can, even with that, you can see the impact of the configuration of these analyzers on a search engine and on the score that's going to show up to the user behind. And it's important to think about this because if you want to use the autocomplete feature, you need to configure your tokenizer well. If you want to process different languages, you need to think about it before start doing anything. And I'm talking about languages. This is the base settings for an English index proposed by the Elasticsearch. I think any search engine can propose their own. You can see that it's going to use the things that are needed for the English language. So if you try to put a French language, French document inside, it's not going to work. It's going to work, but maybe it's not going to work like you would like it to work. So again, if I use some Bulgarian token and settings, there's no reason for me to put English documents in a Bulgarian index, because Bulgarian and English are totally different languages. They don't have the same stems, roots of the words. They don't have the same way to write sentences. There's no way it's going to work. But you can start with this, and you can refine all the way until you find the perfect one. So maybe you found it at the first try because you know everything there is to know about the search engine you're using, and that's fine. But iterating on your configuration is fine too, because finding the perfect match at the first time is quite difficult. Drupal. So with all this information behind us, how we can, while using Drupal, change the settings of an index to put what we want to and what we need inside. So there are many ways to do things. There are many search engines. There are many modules. There are many things. But I choose to use Elasticsearch because why not? I know it's not the most used in Drupal, but I like Elasticsearch. I use the Search API module because why not? And Elasticsearch connector because it's the most used one for Elasticsearch. So that's my way of doing things. There are a lot of more ways, but this is the one I'm going to show you. So if we want to change the settings on an index, we need to know that before the index before the configuration is created in the search engine. Because once it's created, we need to remove everything and then put it again. So we don't want that. We want it to be configured before it's created. And then once we have the settings, we just have to change what we need, add what we need, delete what we need, and we're good to go. And such Elasticsearch connector module proposes different events to subscribe to. And depending on what you need to do, you can choose the right one. So maybe you've guessed, we're going to use prepare index event. And since it's just an event subscriber, it's a classic event subscriber, I think you know what we're going to do, almost. So I can write my function, my method. I can just get from the event all the configuration from the current index. Work with arrays because we love arrays. And change anything I want, delete what I want. Here I'm just adding a filter, a lowercase filter. And that's it. Once it's saved, it's done. It's sent to Elasticsearch. And I have my lowercase filter on Elasticsearch. And we don't need to do anything else. So in the end, there's a lot of things that can change the way a score is computed, because there's a lot of notions that are going to impact this score. You can't have the hands fun. You can't play with everything, but you have the possibility to change some things. And as developers, as engineers, as I don't know, we can make it work quite easily. It's not that complicated. The search engines documentation are quite full of anything you need to know. And you don't have to get the perfect thing on the first try, because that's not how our applications work. Most of the time, we have bugs. We go through many reviews to get the perfect thing at the end. And as I said, I work with many types of projects. So here I use Drupal to show you this example, but the same things work for any other I rephrase my thought. Drupal is just an implementation detail here. So it can work with anything the same way. And I guess that's it. So thank you.
Go back one slide.
Ah, yeah, sure. I have two. You want the first page too? You want this one?
Time for questions.
I was really clear.
Yeah, there's one.
You don't have to.
I'll try to make it easy. So Elasticsearch is a good solution, and I think it works really well. In the Drupal community, we mostly gravitate towards Solr instead, and I think that's mostly a historical thing. And I've heard people say that the only reason Solr is still alive is because Drupal uses it. I'm not sure if that's really the case, but do you think there are differences between the implementations of Solr and Elasticsearch, where Elasticsearch makes more sense even if it's less integrated into Drupal, both in documentation and in like the actual modules configuration?
I don't think there's a lot of difference between both. The idea behind is the same. The only thing will change is the way you configure things, the way you are going to talk with it, if you use an API or something. But in the end, it's going to do the same work. So maybe it's just Solr because it's old and it's used by Drupal and it's still alive. That is more still used than Elasticsearch, but I don't think there's quite a difference.
Okay. So I know a few things about Solr that you can do, like specifically like the learn to rank, where you can use machine learning to change your ranks. Is that also possible in Elasticsearch?
I will need to check it out because since AI is quite in the moment, I haven't looked into it with Elasticsearch. If it's not right now on Elasticsearch, it might be in a few months, kind of, because
Solr has been it's been possible to do like the learn to rank algorithm has been in for at least 6 or 7 years. So I would think it's all the scene, but I'm not sure.
If it's that old, maybe it's already implemented. Yeah. Because, I mean...
It is? Okay.
It is?
Yeah. So, do you want to put the recording on?
So, of course it is, and like I think why Elastic is more popular like in other communities, because it makes more marketing events, and you can even go there and check it out. And yeah, and that's why I think it's more popular. Like we had like previous talks in the morning, like what you do for your marketing and what Solr does for its marketing. And Elastic has like these events that are going around the world, and they are free, and you can go and check it out and talk to real developers who are doing Elastic and ask your questions. That's maybe like the reason for being popular. Yeah.
Thank you. Anyone else? Thank you for your session. It was amazing.